So I want you guys to start working on the task that I have given yesterday. So let's work on it. Walaikum Assalam. I may or I may not, but make sure that you take, at least it is there for 7 days. So that's where you have to go.
Okay. Yeah, 'cause it's- Thank you.
For those who came in late, we are working on the task that I have given you yesterday. So let's continue on that. Most like I'm going to start in next half hour or so. I'm going to start on block architecture. table space.
So it's not going to affect.
So you take an export, and then during the import, you know how we say remap underscore schema from this schema to this schema? You say remap underscore table space to old table space to new table space, and then it will import in the new table space. Yeah. That is one thing. The other thing is you can also use the data, you can also use the move. Alter table name, move to new table space, and then it will move. Right, so alright, so what is the default block size in Oracle? What is the default block size in Oracle?
64?
8?
8.
8 kilobytes, right? So Oracle has different block sizes. Block size. So Oracle block size. So the parameter that controls this is if you type show parameter, db underscore block underscore size. If you type in show parameter block underscore size, and this should give you that your current block size is 8 kilobytes. Now, Oracle has you can create a database in 2K block size, 4K block size, 8K block size is the default, and then 16K block size, and then you have the 32K block size. But if you just use the database and you say next, and you just create it, or you type in create database and it will create a database with 8K size. Now, if you have to start looking into the 8K size, what we are doing is we are saying, okay, so the block that we have is about 8K. And you already know that we have 8 of these blocks working in an extent, and that extent will have given to a, so these are all the 8 blocks, and then you have the first extent, and then this extent is part of a segment. So if you create a table called EMP, EMP is creating a segment called EMP, which is this segment, and then this segment will create the first extent. The first extent is extent 0 all the time. Okay? And then you have 8 blocks in here. So block 1, so let's call it block A, B, C, D, E, F, G, H. Okay, so what I'm going to do is I'm going to zoom into block A here. Okay, so here is our block A. Block A is again divided into 3 different parts. So this is our 8K block size, right? So this is block A, and here what we are doing is we are saying, okay, what is the complete size of this? Total is 8192 bytes. Okay, which is equal to 8 kilobyte. The first part of the block A is something called DBA, data block address. Okay, you can, in simple words, you can call this as a block header. Okay, Oracle keeps its own metadata in it. Then the second part of that is called the PCT free. And then the third part is called PCT used. PCT stand for percentage free, percentage used. Okay, so there are three parts to every block. There are three parts to every single block. So the first part is the database header. So in the header, obviously it is keeping the Oracle metadata. What does this metadata includes? What is the status of this current block? What is the block header, block address? And then what is its status? And then what are the table or segment this block is associated with? Okay. Number of rows this block has. What is the percentage of used? What is the percentage of free block? All these other details it is kept. And then the status can be either free, the block is free to be used, the block is pinned, that means block is currently being utilized by some process, and then the other status that it has is called dirty. Okay, so free means it is available to add more data. Pinned means something else, some other session is currently using, and it may just skip to this block, go to the next one. And then dirty is something that this block is completely being filled, you cannot add more space to it. Okay, and then there are a bunch of other things that it is keeping. So here you have the header part. Header is keeping all this information, and it also keeps something called free list. We will come back to that later. Okay, so now you have this. So if I have the 8192, I will say 192, I'm going to give this here, 192 bytes. Okay, so now I have the remaining 192, so that means remaining I have 8000. Then I give 10% of that 8000 and 90% I give, this is the default structure. 10% and 90% of remaining space after the block header. That 10% and 90% here, so now I have 8000 here. So if I say 10% is 800, and then here we have 7200 bytes. Does that make sense? So if you zoom into any block, the block is divided into three parts. The first part is the header, which is keeping the information about where exactly this particular block is on the disk, which table or segment has the data of which table or segment has, how much it is free, how much it is available, what is the status of the block, is it currently used by someone, then the official word is pinned. Then if there is no space in that, it is dirty. If it is free, then it will mark itself as free. So who is keeping track of what is the current status, right? Free, pinned, dirty, how much it is used, how much it is not in use. Every block maintains something called free list. Think of that as a spreadsheet of each of the block, what is the block address, how much total space given, how much it is being used, after use, how much percentage it is left, how much remaining space that is left. All these details are maintained in free list. Okay. Now, this space is space for new or updated rows. Space for new or updated rows. Here, space for updated rows only. So any row that is being updated, only during that update this space can be used. Whereas this space can be used for anything, a new or an old row. Are we okay so far? Can I erase this? So I'm going to write some few of the points that what we have discussed here. So my WebEx is also open if you guys want to look into that. So let me show you how we can find what is the block size of our database. So I'm going to log in. Florida server. And here if I type show parameter, parameter db underscore block underscore size. So that tells me that the current database that we are using is a block size, or the 8K is the block size. Or we can say and show me any parameter that has the word block in it. So here I can simply type show parameter block, and it is giving you every single parameter that controls the database, or DB block buffer, block checking, block checksum, and then block size, DB file, multi-block, read count, all these different things in here. But if sometimes it is very hard for us to remember exact parameter name. So I usually type in show parameter. If I know that it has something to do with the block, I will say block. If I know that it has something to do with the memory, then I will say show parameter memory. So if there are any parameters that are related to memory, it will show you that. Okay. Then we also have, we know that there is something called SGA, but I do not know exactly what parameter controls the SGA, system global area. So I can simply type show parameter SGA. If I want to know what is the database name, what is the instance name, what is the service name, but I do not know exactly which parameter controls that, so I will type show parameter name. If I know that there are these parameters are related to some processes, but I don't know exactly which process that we are talking about here, then either you give the exact name if you remember, or you can type in show parameter process. So anything, any parameter that controls the processes or of any type, it will list you all that. So the one that we are looking for is processes, or there is DB writer processes, and so on. So it will give you all that information in here. So how many total parameters are there? We can say select count star from $v process, and it will give you all the different processes. Sorry, $v parameter. Select count star from $v parameter. So there are total of 460 processes. So to find out any parameter, right, SQL plus /SSDBA after you log in. You type in show parameter dB block size. Some of the examples, if you don't remember, show parameter block, and it will give you all the parameters related. Show parameter memory. Show parameter. What else did you say?
SGA.
Process.
Show parameter SGA. If there are certain parameters that controls the table, I don't know. Let's see if there is anything that controls how the table behaves. So there are different things in here that will explain that. If I say show parameter indexes, if there are certain parameters that controls the behavior of indexes, then we say index, show parameter index. Does that make sense now? So same thing, if I want to find the size of the block, I will just type in, I know that, or if I say, I know that it has something to do with the size, so I can just type in show parameter size. It will list all the parameters that has the word size in it. And then from here we can look into, oh, this is the one that I was looking for. Okay. These are all the different ways to control your database. So far are we okay? So if I look into 8K block size, or any Oracle block size. So we are talking about the default, which is the default 8K block size. Right? So block is divided into 3 parts. The first one is called the DBA, data block address. And then 2 is the PCT used, and 3 is PCT free. Data block address has the block address, physical block address. What else? The segment information. And then free list. Free list has how much, what is the total size, how much is in use, how much is in free, the status of the block, the status can be free, pinned, or dirty. Depending on that, then your total size, and then there are a bunch of other things, right? Other metadata. PCT used is space, 10% of the remaining space of block. This is used for what? This is used for any rows that already resides in the block, okay, during update. And that's it. And then PCT free is 90% of the remaining space of block. This is by default. You can make certain changes. So this is by default. And this is space is for what?
For new and updated.
For new or updated rows. Okay. Now, I think we have a good picture of this now, so that we can proceed to the next step now. Right? These are the top level things about each of the block. Now, let's say you created a table. Create table T1, and then you put all these details. This T1 is creating a segment, This segment has an extent. Extent number is 0, the default one. Segment name is T1. And then this is also creating 8 free blocks, or it is reserving, it is wrapping up 8 free blocks. At this point, my blocks are all advertising themselves as free blocks. 8 free blocks. 8 times 8k is equal to 64 kilobytes. So even if you have not entered anything, you just created one empty table, 64 kilobytes is given. But if you start looking into each of this has the header part,
and also use.
yeah, and then it also has the use part, and then the remaining space is the free. Yeah. And then for now, we will just say this is block A. And then the user says, insert into T1, and it has given a bunch of other things, values, and it gives a bunch of things, and then the user says commit or not. Let's say commit. Now let's zoom this block A, and then block A will have the header part, okay, and then it has a PCT used, and then PCT free, and this is block A. So the first row number 1 will go in here, and then let's say the space of this row number 1 is 1000 bytes. Yeah. So now this 1000 bytes is being used. So one row is added. Row 1 is added, 1000. So you have 7200, right? Minus 1000, so you have 6200. So the block is still advertising itself as free. Do you all agree? Because it has 62 kilobytes or 6200 bytes. Then user says another insert. This insert is taking, so remaining 6200, and then this insert is taking about 1200 bytes. So now I have 5000 bytes available. So now let's say this insert is taking about 1200 bytes. Row number 2. Now is it still advertising itself as free? Yes. All the blocks are still advertising themselves as free. Now I have another insert. This time it requires 4000 bytes. Okay. So now I have 5000 minus 4000. Now the remaining is 1000. However, the percentage of the block is reducing, and then free list is actually keeping track of that. So now I have about 4000 bytes. So this is row number 3, and row number 3 is taken up this much space in here. Then user says, I want to update. This update is for row number 1, and then instead of from 1000, it is actually bumping it to 1800. Okay, so now if you think of that, row number 1 is, so remaining I have 1000 left, right? So out of these, this is row number 1 is continuously, because it has some updates, it has taken about this much space, and about this much is still free. Are you all okay now? Yeah. So next insert. Row number 4 is taking about 700 bytes. Yeah. So at this point, what should we do now? So I have only about 200 bytes available here, but I still have 800 bytes available here, and this is my DBA. So my percentage used, and then this is percentage free. In percentage free, I have about 200 bytes available, and in percentage use, I have about 800 bytes available. So what should happen now? Should it go to block A or some other block now?
I think it goes on the BTC used the raw one because it's update, we updated that one.
Look at this. Are we updating anything?
No, previously where we updated that one, the previous one, so I think it
The
goes
previous one is using, because it has the free space, it used the free space in here. So this is our block. The first part is the block address. This is the 10%. It can take inserts as well as updates. Sorry, this is only for updates.
updates.
Yeah, this is for insert or update.
Okay. We'll update that one.
Okay, so now at this point, so this is row number 1, this is row number 2, this is row number 3, this is row number 4. Now row number 4, during the insert, user has updated something and there are 700 bytes that it has to write. So my question to you is, I have 200 available here, I have 800 available here, and then the required space is 700. So where does the data go now?
New block.
New block. Why? Because this is only for update, but this is insert. And for this insert, it requires 700. So can it use 200 here and then go to the next one and use the 500 there? Let's put the block 2 into the picture now, block B. So now I have the block B in the picture. Block B is also again divided into 3 parts. Here's the DBA and then percentage use and then percentage free. So here it is 800 bytes and you have 7200 bytes available here and then block B. Now what is the status of the block B now?
Free.
At this point it is free. But as soon as the transaction starts, what is the status of it now? Pinned. Yeah? So now at this point it has to insert 700. So at this point it is still advertising itself free. But as soon as the transaction starts, then it will say I am in now. If there are any new more updates that are coming from other session, try to use another block. Don't touch me. Right? So at this point, how many of you say that we split the data or we can just move the entire row in here? Split the data mean I can use 200 here and I can use 500 here.
So it's gonna take, I think, 700 for the new block.
Why?
It's gonna keep their 200 for, because that area is for insert and update. In future we do update, it can take that 200.
Okay.
We
And
already have the updated
but
section.
it can still, I mean, yes, that's a good idea, but why not use 200 here and 500 here?
It'll be cleaner if it's all in one.
It will be cleaner and
It's all
faster. Now imagine if I ask you, hey, can you go get this from this building? It will be a lot easier for you to go get that from that building and come back. Yeah? But if you go to that building and then that building says, oh, you know, half of the stuff here and then half of the stuff is in blocks in some other building. Now it will be slow for you because you are going to the first building, collecting the stuff, going to the second building, collecting the stuff and then coming back. So your transaction has many different routes now and then it has more lookup, going to the place, reading the data, coming back. So what the Oracle does is, if it cannot have the entire row in here, it will not split that row, it will actually move the entire row to the block. So now you have block 4, so 7200, 800 is, 700 is taken, so now you have 6500 available. Okay. Now, there is an update now. This update is same row number 4. Now instead of 700, it is saying that I want to go to 1200 bytes. So because this is an update now. Now row number 4 is sitting here. Or sorry. Sorry. Go back to, let's say, this is row number 4, right? So let's say row number 5 or row number 3 again, update. So row number 3 is still in block A. and it has taken for 5,000 bytes, right? So row number 3 is saying, I want to grow from 5,000 to, currently it is 5,000, I want to grow to 5,800. What do you think will happen? The entire row moves, or we can capture some space from here.
Now the update section.
So it requires about 5,
800.
how much?
800 more.
800 more, right?
Yes.
So 800 more, it says, because this is an update, I'm going to take this space and then I will take up this space. So this is again part of row number 3 now. Yeah, so it will take about this much space. So how much is available now at this point? So 800 plus 2 is 2000. So now I still have 200 available, but it is only for the future updates. Okay, so what is the current size? 5800 of row 3. Row 3 has another update. Now at this point, what is the block status?
Ready?
This is dirty now. Okay. So this block status started out free, and every transaction it is pinned. Now it is dirty. Why? Because this entire space, no space is available for free or new rows. But there is some space available only for the rows that resides inside it. Make sense? Okay. So now we have row number 5. Row number 5, in here I have 6500, right? So now I have another insert here. This insert says I have about, for row number 5, I need about 10,800 bytes. Do I have 10,800 bytes available here? Do I have another 10 kilobytes available here? Yeah? So I will say, okay, maybe I have to look into another option. That option is check into a new block. But the new block again is going to have the data block address, and it is also going to have percentage used, percentage free, and then DBA. So this is block C. Now for the block C, if I have to look into this, the maximum space I'm going to get is 7200. So how can I fit in here 10,800 bytes, or let's say 11,000 bytes?
Can you not change the block size?
Sorry?
Can you increase the block size?
Okay, but at this point, once the table is created, it is created. You cannot change it. Once the database is created, it is created. There are certain other things that you need to do. But at this point, in general, the block size is on the database level. If I try to fit that 11,000 here, it says no. 11,000 here, it says no. Even for a new block, it says no.
Use two blocks together.
The only option that Oracle has is now is basically it is saying I'm going to take 6,500 from here and then 5,500 from here. And this is called row chaining. Oracle official word is row chaining. Yeah? But for the row chaining, do you think it will take this entire space, or do you think it will still keep it as free?
Free, that's free.
Still keep it as free. Because that is a new insert, not an updated. Yeah? But remember the example I gave you, where you have to go get this from two different buildings. I still have the same case here. One building here, one building here. So I still have to go here first, and this header will say part of some of this information is here, part of that information you have to go and talk to this header. So now your session, so your session is basically coming and talking to this, and this guy says I have some information here. And then once you are done with this, go and talk to this, and this guy will say, I have some of that information here. Even if you put like 1 nanosecond for each of this, going to this one here, 1 nanosecond, and then saying, go here, and then 2 nanosecond, you have the row. Whereas if you come here, 1 nanosecond, 2 nanosecond, 3rd nanosecond, and then here it will say 4 nanoseconds, right? And then you capture this data, and then you capture this data and send it to the user. So the time is almost doubled in here. So row chaining, Oracle identified the row chaining as a problem. Why? Because it will reduce the reading time. Not just the reading time, I can say write
Increase.
time also. So basically the problem is I/O related issue has been identified, is being identified. So your ASH report or AWR report will start seeing this as a problem.
Increase the reading time, right?
Increase the reading time and also during the write time, during the update time.
You reduce the
Reduce the, increase, sorry. Increase the reading time and also the write time. So row chaining is a problem. So this is one problem that we have identified. Okay. Is there anything else that can be identified or could be a problem? Oracle says yes. Why? Because when you insert a row a row is given a row ID. That means for the life of this row ID should not change. Okay? For the life of this row ID should not change. But what will happen? Let's say you have this 1000 bytes available here, right, for the row number 1. So row number 1 says update row 1. Yeah. So the previous it was 1000. Now the next one it is 1500. Now this is already advertising itself as not free. This is dirty block, right? So this has to be increased to 1500. But if I start looking into this part here, only 200 is available. So again what that means is, for this I have to put 1000 here at the bottom, then maybe 200 here from the percentage update. And then what about the 300 remaining is still there? Should I move to a new block? No. If I do the part of this into a new block, then I am increasing the row chaining again. And we want to avoid the row chaining. So what is the solution for this then?
moving the whole data to a new block.
Moving the entire row to a new block. So Oracle, what does that do is, Oracle says, I don't have this 1500 available here. So I'm going to make a copy of this entire data, add the additional 500 to here. Once I have this, then I'm going to erase this from here. Yeah, row number 1, and then some of the row number 1 was also here. So now immediately it is advertising itself as free because it has taken some of the values from here and there. Right? So the new value, it is 1500 and it has to migrate. It says, do you have any available space for new? No. Do I have any available space for new? Yes. Here, row 1 is being migrated. But wait a minute. So do you think this is a good solution?
How many times it's going to keep this moving?
Remember I said whenever a row is created, a block row ID is being given. The row ID that is given is related to this particular block, not a new block, not the future block. So your row ID will never change. So your session will still have to come and talk to this guy. And this guy say, yes, this particular row was part of
See,
me in the past. But now this row is being moved in here. So again, instead of having 1 nanosecond and 1 nanosecond here, now I have 1 nanosecond, another nanosecond here, and then you come back and you say, I'm going to get that from here. So the time has increased. Yeah, do you understand that? It cannot fit everything because I don't have any updated space, and then I don't have any enough space in here. So this problem, Oracle says, when the row is moved, this is a problem in I/O, both input and output. And Oracle has a name which is called row migration. Row migration is also given as a problem. So there are two problems that we have identified. One is row migrating. So imagine this. I used to live in Bolingbrook, then now I moved to Palos Park. But my address still says Bolingbrook. So all my mails are going to Bolingbrook, and then somebody coming out from that home and say, hey, Mohit does not live here anymore. You have to go to this new address. Now that same person has to drive all the way to Palos Park. So it could be a lengthy process. So row chaining is definitely a problem because multiple blocks, multiple buildings has to go and get it. Row migration is also a problem because the header cannot be changed. The only way you can actually change the header is you export the data and you import the data back. Because now when you are exporting and importing, you are getting a new row ID. Or move the table from one table space to another table space. Or copy the table from old table space on old table to new table and then rename the table. You have to do some of these tricks, otherwise it will never give you the solution. It will always be slow. So a database which used to work, so let's say on January 1st you created this database, you installed this application. From January 1st to January 2nd, performance, January 1st to February 1st, performance was optimal. No complaints at all. Then February, then March, April, every month you are realizing that your application is slowing down. By the time it is in June, application time, response time is doubled. By the time it is in December, by the Christmas, or in August or September, you are seeing the same thing which used to take 1 millisecond, now it is taking 3 milliseconds. So now you are into e-commerce. You are heading into the Christmas time. Now you know the traffic is going to double. If the traffic is going to double and while my database is already taking 3 times longer, that means we are heading into a big storm. Your database can even crash, right? So in that case, we have to identify, first of all, you have to identify where is the problem. If the problem is related to I/O and from your AWR report, then maybe you can start looking for what is the cause. And if it is slowly, steadily growing, the response time, the chances are there are more updates that are happening to the database. Due to these updates, the rows are migrating to different places. Imagine you have C drive, E drive, F drive. So now part of that, let's say you have a problem where the row chaining is occurring. So you have the C drive and then you have the E drive now. Not even the same drive, it is going to 2 different places. Some of the rows started from C drive, now it is on D drive now, or it is in E drive. So now you have multiple lookups, not in the same disk but also multiple disks. Can I erase this now? So databases are two different types of databases. Okay. One database is mostly reads. Okay. For example, in e-commerce. Right? In e-commerce database is how many times Amazon is actually changing products. They have the same product ID, same product, maybe the prices will go fluctuate up and down. So not many times, right? Or imagine post office. How many times post office is actually coming up with new zip codes, new states, new cities? Very rare. Yeah. So these type of databases are called as static databases. Okay. The values are mostly constant; they are not changing. Okay. And then you have another database which is mostly read and writes. Read and writes. For example, stock market. Yeah. Data warehouse. Data warehouse where the data is coming from multiple data sources and it is combined together, so there are more writes. So in these kind of databases, Oracle has a name, and this is called the dynamic, where the changes are mostly constantly being changed. This is called OLTP, Oracle Online Transactional Processing, and then OLAP, Analytic Processing. Okay. So in these kind of databases, you will not see any row chaining or row migration is not a problem. Mostly not a problem. Mostly not a problem. But it can happen. Here, row chaining and row migration has to be tuned. And the best way to tune the database is before you actually install the application or design the application in a way that this can take care of itself. So for the row migration, let's look into the row migration here. Okay. For the row migration, we have already identified the problem where a row is here, then this row is somehow moved to another one here, and then this is somehow the row number 1 is now here, and then after that, because this does not have enough space, then it can move somewhere other. So this is a problem. Rows keep migrating, but the same data header is there. What can I do at this point? Now remember, if the default setting of block is, here's the DBA, here's the percentage PCT used, is 10%, and PCT free is 90%. So if I have a segment, let's call it T1. So instead of designing something like this with the default setting where PCT used is 10 and this, how about if I design something like this, where I'm saying the T1 segment should have the block header, and then I want to keep PCT used as 60% and PCT free as 40%. What does that mean? I can only fit few rows in here, maybe 1 and 2 and 3 rows. If they ever need update, they will always come up and read this data only. Because now they have 60% of their space is just reserved. What that means is for next 10 years, the rows are not updated. It is still going to be waiting for it to get updated, so that instead of going to another block, it can always play in the same block. Yeah? So it's a very simple command. We will simply say create table T1, and then you give all these values, and you say PCT used is 40%. Or I think it's either one of those. And then the remaining is the other one. I think it's called PCT free is 60. We execute this. So in the past you were just executing here, right? So it was taking the default settings. So instead of executing it here, you just say PCT free is 40%. Either free or the other one. PCT free, actually we bumped it up to 60. So that means the remaining, the other is only 40% left. So do you think this can be implemented for the tables that you know that are going to have large updates? So for example, if you have a table which has the zip codes, you can just leave it to exactly like this. Whereas you know that price is going to fluctuate, it is going to have a lot of updates, why not design the table something like this? If this database is 400 gigabyte in size, this same database, because you are reserving so much space in here, this could be easily, so if this is 300, right, this could be exactly 1000 or 900, 3 times more or something like that. Yeah. So now you have more space reserved in the database, but the database is fatter. Why? Because you have a lot of empty space. But the good thing is, you are getting the response time back. The rows are not being migrated to another block. So the lookup, so imagine, instead of having a warehouse which is 90% full and then you have to keep relocating the things, when you build that warehouse, you only keep only 40% of the warehouse for the new things. Yeah? And then those things can be relocated here and there if it ever needs space. It is not going to move part of the stuff here, part of the material in the other warehouse. Thus, you are reducing the row migration. Make sense? Okay. Now comes to the row chaining. Can I erase this now? Yeah? Now, we have not talked about SGA very much, but I'm going to just give you a small glimpse. Okay? Let's say this is your SGA, System Global Area. System Global Area, think of this as a water park. Okay? In this water park, you have some more different areas. So there is one area here. This area is divided into multiple pools, like 3-year-old, 10-year-old, 12-year-old, things like that. There is one largest pool, this is mostly for the adults. Okay? And then there is a circular pool. And then you have some other pools here, and then some other pools here. Okay? So for example, I'm going to give the names, and then we will come back, and when we do the SGA, we will look into it. This is called Data Dictionary Cache. This area. This area is called library cache. And then you have this area which is called results cache. This area is called keep pool. This area may call Java pool. Inside the memory, you have different pools in here. And this is called log buffer. There may be another pool here called large pool. And there are some other different pools here, right? So we don't really, some of the maintenance or management pools are here. The 3 main pools that we have to understand, oh, by the way, this area, this entire area here, which has divided into multiple sections, these is called shared pool. data is being shared with multiple users in here. We will talk in great details later on. But for this particular one, we are interested in a pool that is called buffer pool, and this is the largest pool in your SGA. Buffer cache. Now, buffer cache is splitted into the same size as your block size. So if your block size is 8K, then the buffer. So if the 8K is reserved into, so here, if the block size is equal to 8K, the space in the disk, so let's say this is your U14. This is your U14, this is the actual disk. So the block size here is all divided in here, and this is called, so this is on the disk. On the disk, the space reserved is called 8K, is a block. Okay, that is called a block. But if the same 8K is moved into the memory, yeah, so this is your buffer cache, and this is memory. Yeah, so now I have whichever the block size is, Oracle says the buffer size has to be the exactly same. Okay, so now if I am copying this entire block in the memory, the name of this is buffer. So every time you are hearing and then the buffer is also the 8K size. So the same data, if it is on the disk, it is called a block. The same data, when it is copied into the memory, into this particular pool, it is called a buffer. Does that make sense? So remember this. Your SGA is the big memory pool. In that big memory, you have smaller sections of memory, and each has their own tasks. We have the shade pool. This entire thing is the shade pool. But inside the shade pool is again divided into multiple parts. So this is one part, this is another part, this is another part, and it may have a few other parts as well. Okay. Then we have another separate pool, keep pool, Java pool, large pool, and then there is a lock buffer. We'll talk about this later. But the main one that we are focusing now is the buffer cache. Does that make sense? Okay. Why? Because when you have the database, so imagine you have the database, batch 55, and then there is one block that is sitting here. That block is being copied into here. So here the name is called block, here the name is called buffer. So far okay? So do you understand that whatever the block size that I have here, I have to have the same size of buffer in here. Everything, are we all okay? Okay. I'm going to erase this now so that we can continue. Because I think, never mind, just go ahead and do this. I should have shown you the SGA first before we come to this picture, so that's why we have to introduce this now. So without this projector light, I'm not sure how, is it dark in our YouTube video? Or is it okay? Ask the users or remote users. Maybe I'll turn on the light then. Is it better like this or better with the projector light?
It's okay, I think.
Sorry?
It's okay, it's clear.
It's okay? All right. Now, remember our problem, the problem that we have is related to what? So we already have the solution. So solution to row migration. Right? First thing is to identify table. Identify row migration tables. And then create new table with bigger BCT free, and then import the table, import the data into new table, and then drop the existing table and then rename the new table. This is one solution, solution number one. Solution number two is alter table move. Alter table move. Using this, you can get what you are looking for instead of doing all this manual way. Option 3, solution 3 is export schema and then import schema. Yeah, so we'll get the new row. So row chaining. So solution to the row migration is this. What about the row chaining now? With the row chaining, you have the block here and then you have the block here, and they both are chained together. Not only that, but what if the block, if the more data is being added to it? So now there are 3 blocks. So 8K here, 8K here, and then 8K here. First it was only 8K, then second it was 8K, 8K, 16K. Then the third one, the third time it add more space, now it is at 24K. Okay, so the more it is being added, and it could be from C drive, D drive, E drive, this could be for U14, this could be U88, this could be U98. We don't know where the blocks are. So the only solution that you have is get a bigger block size. So instead of 8K block size, we have how many different options that we have?
1632.
We have 2K, 4K, 8K, which is the default, and then 16K. 16K is still not enough for me, so then I have to go into 32K block size. So what we'll have to do is, we'll have to, so let's say this is part of T1 table. Yeah. For the T2 table, for the T1 again, what I have to do is, so this is all part in one table space. So let's say this is users table space. Users table space is built on 8K. Now I have to create a new table space, and I have to call this as users 32K or something. Okay, users 32. And then once these are created, so now this is the 32K block size and it has the header part. And then even if I keep 10% here, I'm still getting 24,000 minus 2,400. Yeah. So we are still getting how much? Almost 22,000 in here. So we have 22,000 and our requirement, 32, right? Sorry. We have 32K and the requirement is 24K. So I still have about that much space left here. So all these data is completely moved here. 22K in one block only. Okay? But Adnan just suggested answered that to me, why not move to a bigger block size? And I said, no, once the database is created, you cannot do anything else. Once the database is created, why? Because you have the buffer, SGA, the largest buffer that you have is 8K buffer. But the problem is, what if I have to fit this entire block, which is 32K, in here? Do you think my buffer will take that? Now I have not just the row chaining problem, but the buffer chaining problem will get introduced with this. Oracle says, no, you cannot do that. Once it is created, it is created. However, what you can do is, you can increase the SGA size and create a new buffer to fit 32K blocks in here. So now I have this buffer
16.
cache, and now I have 32K buffer cache. A new cache has to be introduced first. So before you actually migrate this, the first step is to create the buffer cache, otherwise it will not allow you to migrate. Then the second thing is to create the new table space with 32K block size. And then the third space is to migrate this here, and this can be done by export import with the remap table space. Remap underscore table space is equal to, initially it was coming from users table space, now map it to user 32 table space. So all the prerequisites are done now. Beforehand, what did we do? The first thing is we created a new buffer, so your SGA has to be increased, a new buffer pool has to be created. Once that is done, then create a new table space. Don't add any data into it. Create new table space, and then finally export import, exporting the data. During the import, you are saying going to the new users table space. So you migrated this entire data. You remove all this data from here, which is 8K block size, and migrate it into bigger block size table space. That's one way. The second way is you can also move. Alter table move. Alter table, table name T1, move to users 32 table space, whatever that command is. I don't remember the exact command, but something like that. That way, it is moving, it is not, there is no downtime, and then it was completely moving from, and then this is online moving as long as you are using the enterprise edition, and then you move to the new table space. The third is, you can also say, create table as, which is called ctask method. Ctask method is, you will say create table T2 table space users 32 PCT free if you want to add more data, so maybe 20%, as select star from T1. The table is created. So a copy of this particular table, which has 3 rows, which are migrated, is copied in here. Once this copy is done, then drop T1. So this table is dropped. Once that is done, then you say rename T2 to T1. Okay? So this is how you migrate. So there are different methods. So the first thing is to identify the problem. In your AWR report, in the top wait events, if it says I/O, there are different wait classes. There is a wait class of networking, there is a wait class of I/O, there is wait class of concurrency, all these different things. So if you see the wait class is I/O, then that means you have the slow disks, or you have the row chaining and row migration problem.
I had a question. I mean, everything is in nanoseconds though, but let's say moving a table from one table to another table, that's also time consumption, right?
But it is online.
So while it's being migrated, there is downtime as well.
No downtime. Oracle has its own method. It is completely transparent to the user.
And it will
But
be a
if you are
one-time.
using export import, then yes, there is a downtime. If you are using this method, yes, there is a downtime. But with this alter table move, this is an online method. It is slow, but it can finish the work. The fastest is the exporting route. Yes.
Sir, the way we create table spaces, we have an option to like a max size unlimited
Yes.
and auto extended. Why we cannot do with the block?
No. Once the table, see, all these blocks are part of extents. Extents are part of segments. Segments are part of table space.
Mhm.
So once you create the table space, your size is defined at that moment. So user's table space, by default, everything is going to user's table space.
Mhm.
By default, user table space is 8K.
Yeah.
Your table rows are the tiniest block, tiniest group of bits and bytes together. That tiniest unit is called one block.
Yeah.
So by default, it is 8K.
Okay, yeah. The thing is that we still have an option for 16K and the 32K. Why we cannot do like a auto like extend when we have a bigger row and we cannot get fit in a
Auto extend is an option only for the data files.
Okay.
Data file is part of table space.
Mhm.
Table space says when you auto extend it, the smallest chunk is 8K now.
Okay.
So even if it is auto extending, it is only using 8K chunks.
Okay.
It cannot have bigger chunks. The bigger chunks only happen in the bigger table space. Because when you add the data file or resize the data file is being resized or added, but the chunk size is now 32K. So when you say auto extend on, the chunk is only 32K also. So more blocks that you are adding, each block is 32K. Does that make sense? With this, I am going to end our class here today. Next week, I am making this mandatory for all the online students. If they are watching me or going to hear me later, all the students has to be in class because we are not going to share the live video. Number one. The video recording will be given only to the students who are in class because going forward everything is getting more challenging. I want all my students to be in class. So do not ask me for video recording later on if you are not in present or if you have not made prior arrangements with me. Don't tell me that I forgot to call you or if I forgot to email you. I'm sorry, I'm not going to take any of those. So make this as an exception that you have to be in class. No other excuses are allowed. This is all for online students. Alright, that's it. Inshallah, I will talk to you guys later then.
We have a question.
Yes, sir.
So we have two types of dictionaries, $3 sign and the DPA table spaces.
One are called the
Why like we have two types of dictionaries? Why only one? And the thing is like,
one is available during the mount state.
okay.
The other ones are only available after the data is open. So during the mount state, so $V will work, but the DB underscore may not work.
And
Okay, Allah Hafiz.
Okay.